Hi dear students, welcome to PMSH classes. This is the lecture 6 of motion in a straight line. In this lecture, we are going to discuss slope and area of different graphs. And those graphs include displacement time graph and velocity time graph. This video will be useful for students who are going to attend CBSE board examination and Kerala state board examination, and also for students who are going to attend competitive examinations like Team KVPY, NEET, JEE, etc. So without much delay, we will discuss the topics. So first of all, let me tell you a mathematical operation that help us to find the slope and area of different graph. Okay, that is slope of a curve. We have already seen in the previous lectures what is slope of a line and how to find the slope of a curve. And the slope of a curve is basically found using the mathematical operation differentiation. So you can note that, you can take a note of it. Differentiation is the differentiation is the slope of a curve. Okay, differentiation is the slope of a curve. And so we have seen that what is slope. Slope means we can found it using mathematical operation called differentiation. Then we want to know what is area. Area is basically integration. Okay, so we can say integration is the area under curve. Okay, so in the upcoming lectures, I will teach you how to do differentiation and how to do integration. And we will be doing some numerical question in order to understand differentiation and integration. And it is very important for all competitive examination and even including board examinations. Okay. So first of all, you understand for a curve, if we are finding the slope means we are differentiating. Okay. Then finding the area means we want to integrate. Okay, we want to integrate so that we get the area under the curve. Clear? And now we will start with, you can take this note. Okay, you can note it in your notebook. Now we will come to displacement time graph. Okay, so we are going to see some general things about displacement time graph. Then in the upcoming lectures, we will discuss about the graphs for different kinds of motion and all. But the base starts from here, so it is very important. Okay, so we'll start with displacement time graph or even ST graph. S stands for displacement and T stands for time. Okay, so let us draw a displacement time graph. This is T and here is displacement. You can put it S or you can mark as X. Okay, suppose this is a displacement time graph and there are 2 points. Okay, on this graph there are 2 points. One of the point is T1 comma x1. The first point coordinates are T1 comma x1. We know we will mark the x coordinate first. Okay, then we will mark the y coordinate. So here the x coordinate is T. Okay, this is x axis and this is y axis. So x coordinate is T1 and y coordinate is x1. For the second point, the x coordinate is T2 and the y coordinate is x2. Okay. Then how can you find the slope? If a line is given and 2 points on the line are given, you know how to find the slope. We have came across it in the previous lectures. The equation was slope m is equal to y2 minus y1 divided by x2 minus x1. Okay. So applying this formula here we get y2 minus y1. That is here x2 minus x1, right? They are the y coordinate. X2 is the y coordinate for the second point and x1 is the y coordinate for the first point. So it will be x2 minus x1 divided by the difference of the y coordinate, sorry, difference of the x coordinate, right? X2 minus x1. That means t2 minus t1. Okay, clear? T2 minus t1. Okay. So actually what it is? X2 minus x1 by t2 minus t1. That means it is that m is equal to x2 minus x1, right? You can see here x2 minus x1, that is delta x. What is delta? Delta means change. So that is change in x. X2 minus x1 means change in x divided by t2 minus t1, that is change in the time. Okay, that is delta t. Okay, delta means change. Okay, so the equation becomes the equation becomes delta x by delta t, that is change in the position by change in time. We know that it is nothing but velocity. Okay, change in or displacement by time, right? Displacement by time. It is similar here. X2 minus x1 is the displacement and change in time is delta t. So this is equal to v. Clear? So I hope you understand this. Okay. Now see here. If limit delta t tends to 0, if limit delta t tends to 0, okay, I have already told you what is tends to, what is limit delta t tends to 0 means. This is all we have discussed, right? So limit delta t tends to 0, then we have dx by dt. Clear? The slope becomes dx by dt. So we can say this velocity v is equal to dx by dt. Okay, so we get v is equal to dx by dt. Clear? So from here we can conclude that velocity is the slope of displacement time graph, isn't it? The graph was a displacement time graph. Okay, this graph is a displacement time graph. And for this displacement time graph, when we found the slope, we get that slope is nothing but velocity. Clear? The slope is nothing but velocity. So we can conclude. Velocity is the slope of displacement time graph. Okay. Clear? Or this is basically differentiation, right? This is basically differentiation. So differentiation means you can derivative. Okay, you can call differentiation as derivative. Okay, so you can say like this also. Velocity is the first derivative of first derivative of displacement. Okay, I hope you understand this. Okay, that means we got the equation v is equal to dx by dt, right? So x is basically displacement. Okay, x is basically displacement. So we are differentiating the displacement. Okay, how many times we are differentiating? One times. Okay, we are differentiating the displacement one time so that you get velocity as the answer. That is what we have told. Velocity is the first derivative of displacement. And in the upcoming lectures, I will tell you how to do it in questions. Okay, how to apply this formula in numerical questions. Okay, you have to learn a little bit of formulas for that. We'll come across all that. But now just understand velocity is the first derivative of displacement. Okay, it's a mathematical process. Okay. Now, we have found the slope, right? Now, let's see. We will integrate that equation on both sides. Okay. Integrate both sides. What we get? Our equation was V is equal to dx by dt, right? Sorry, we don't want to integrate now. We'll integrate after rearranging this formula. Okay. After rearranging this formula, we will integrate it. Okay. So let's take dt to the left hand side. So we get dx is nothing but v times dt. Okay. Dx is nothing but v times dt. Now you integrate both sides. Integrate both sides. Okay. So what we get? Integral dx is nothing but integral v dt. Clear? Integral v dt. Integral dx means it is x. Okay. Integral dx answer will be x. So x is nothing but integration of v dt. It's an important formula. X is nothing but integral of v dt. What does this equation mean? X is the displacement. X is the displacement. And vdt means it is velocity. V stands for velocity. Okay. So we are integrating the velocity time graph. We are integrating the velocity time graph. Okay. And I have told you at the starting of this lecture, integration means area under the curve or area under the graph. Okay. So we are finding area under the velocity time graph. You get me? We are finding area under the velocity time graph. In order to find the area, you make use of this integration. We make use of integration. It is the mathematical operation to find the area. Okay. So we are finding area under velocity time graph. We will get displacement. So that's a very important point for doing problems. Okay. You can tell that displacement is the area under velocity time graph. Okay. Displacement is the area under velocity time graph. And the equation is x is equal to integral v dt. Okay. Clear. So we have, now we will discuss, yeah, velocity time graph. Okay. Now we will discuss about velocity time graph. So I'll draw a velocity time graph here. The y-axis will be velocity and the x-axis will be time. Okay. Similarly, consider a line and there are 2 points on the line. The first point have the coordinate as t1, v1 and the second point have the coordinate as t2, v2. Clear? So what will be the slope? The slope m is y2 minus y1 divided by x2 minus x1. Okay, this is an equation you already know. Now let us apply these coordinates into this equation. Okay, substitute it. Change in y coordinate. Y coordinate is nothing but Here it is v2 is the y coordinate. Here v1 is the y coordinate. Okay. So it will be v2 minus v1 by what is change in x coordinate? That is t2 and t1, right? So it is t2 minus t1. Okay. So v2 minus v1 means it is a change in v. T2 minus t1 means it is a change in t, that is change in time. Okay. So actually what it is? Change in velocity with respect to time. I have already told you what is acceleration, right? We have discussed when we was discussing about uniform motion and non-uniform motion, that I have told you acceleration is change in velocity. So change in velocity here, delta v by delta t, that is nothing but acceleration. That is nothing but acceleration. Okay. So we can say that suppose limit delta t tends to 0, limit delta t tends to 0, then delta v by delta t becomes dv by dt. So we can say A is nothing but dv by dt. A is nothing but dv by dt. Okay. We'll go to the next page. A is nothing but dv by dt. This is our equation. Okay. And all of you know what is velocity, right? Velocity is the first derivative of displacement. That is v is equal to dx by dt. This is the equation we have observed in the previous slide, right? V is equal to dx by dt. So upon substituting this v over here, okay, upon substituting this v on here, what we will get? I'll just show you. This equation A becomes d of dx by dt with respect to dt. Clear? This is mathematically written as like this. I'll show you. That could be written in simple manner. A acceleration is equal to d square x by dt square. This is also a formula to find acceleration. Okay. Now I will tell you what the first equation means. The first equation means that acceleration is the slope. Okay, differentiation means we are finding the slope, right? So it is a slope of velocity time graph. We have observed when we have found the slope of a velocity time graph. Here is a velocity time graph. And for this velocity time graph, we have found the slope. We got acceleration. Clear, we got acceleration. So you can tell that acceleration is the first derivative of velocity, or it is the slope of velocity time graph. Or you can even say here d square x by dt square. Okay, d square x by dt square. What does it means? It means derivating the displacement two times. Okay, d square by dt square. That is second order derivative. Okay, which means that you are derivating displacement two times. So when you derivate the displacement one time, you get velocity. When you derivate it again, you will get acceleration. Okay, I hope the things is clear. Here is displacement, here is velocity, here is acceleration. You are derivating this displacement once, you will get velocity, and you are derivating displacement two times. Okay, d square x by dt square. You derivate it once, it will be here. You are again derivating that, then you will get acceleration. That is what this equation means. D square x by dt square. You are derivating the displacement two times. Okay. Or you can, if you directly get the velocity, you derivate the velocity once. You will get acceleration. That is what this equation tells you. A is equal to dv by dt. So from here, we can conclude acceleration is the velocity time graph. Okay. Or you can even say acceleration is the first derivative of velocity, or you can even say like this: acceleration is the second derivative of displacement. Clear? Now let us integrate. We'll rearrange this formula. We know now A is nothing but dv by dt. Now upon rearranging, you get dv is equal to A times dt. Let's integrate both sides. Integrate both sides. You get integral of dv is nothing but integral of A dt. What is integral dv? Integral dv will be v. Okay. V is equal to integral A dt. So you remember this formula very well. A dt. Clear? So we get V is equal to integral A dt. It means that velocity is the area under acceleration time graph. Okay. Integrating means you are finding the area. So A means acceleration. So you are finding area of acceleration time graph. You will get velocity. Okay. So you remember that. Velocity is the area of acceleration time graph. Clear? Now, so in short, okay, I will conclude all these contents that we have discussed today. In short, you can say, just draw this figure in your notebook so that it becomes very simple for you to remember. Displacement. Okay, just make it some big. This is displacement. Velocity. Acceleration. Clear? Now, from displacement time graph, if you want to go to velocity, then what you do? If you want to go from displacement to velocity, then you will find the slope. Okay, you will find the slope. What is the equation for finding slope? V is equal to velocity is equal to the slope of displacement, that is dx by dt. Clear? Now from velocity, if you want to go to acceleration, then again you have to find the slope of velocity time graph. So the equation for acceleration A is dv by dt. Is this clear? Now from acceleration time graph, you want to find velocity. Then what you will do? you will find the area. Okay, the area of acceleration time graph will give you velocity. So what is the equation for velocity? Velocity is integral A dt. Clear? Now, from velocity time graph, you want to move to displacement. Okay, so what you will do? You will again find the area of velocity time graph. So the equation for displacement. Okay, displacement is integral V dt. You can put either x or yes. Okay, that's your wish. X or yes. For velocity is V. For acceleration it is A. Clear? So this is how we find different graphs and different values, that is velocity, acceleration, displacement, etc. from different other physical quantities given. Okay. So in the next lecture, we will be discussing some important graphs. Okay. That is, we will discuss some basic concepts about graph. Then we will discuss body at rest, body having uniform motion, body having uniform acceleration, and also some graphs that cannot exist. Okay. So see you all in the next lecture. If you like my videos, then please subscribe the channel, like the video and share it to your friends. Okay. See you.